An experimental feature in Node 22 will finally allow ESM code to be required in a CommonJS environment, meaning you'll be able to use ESM-only libraries like Arcjet in frameworks like NestJS. It's really simple to do. Let's jump straight in and get it working. If you're anything like me, you've got the LTS version of Node running in your development environment. Currently, that's version 20. These experimental features that we're about to look at are in version 22, so we need a way to be able to switch between Node 20 for our regular development and Node 22 for our test today. We're going to use NVM, or Node Version Manager, in order to select which version we want to run. First thing we want to do is go and install Node Version Manager. So let's have a look for NVM. We'll find the GitHub repository here. There'll be a link to that in the description below as well. And if we scroll down to our installation, we can see down here that they've got a number of scripts that we can copy and paste into our command line. Now, generally, copying and pasting curl commands into command lines is something you should probably double check that you know what's actually going on and having a look at the code. Because this is in their GitHub repository, I'm fairly confident that this is going to work for me. So I'm going to copy the curl command here, and I'm going to run that in my command line. Now, I've already done this, and I've followed the following example here in order to load the paths in so that NVM now runs. So if we switch over to my command line over here, we can see that we have NVM running. We can use NVM to install various versions of Node. If you run NVM install followed by --LTS, that'll install the long-term support version, currently version 20, or you can come in and say you want to install version 22. I've actually installed both of those, and once you've done that, if you run NVM ls, you'll see the versions that you have installed on your machine. You can see here I've got version 20 and version 22. We're currently using version 20, you can tell by the arrow there, in anything that we run in this environment. If I type in nvm use 22, we're now going to switch over to using Node 22 and npm version 10.8.2, which is the corresponding version of the Node package manager. Any code that I now run in this terminal window that requires Node will run Node 22. But because my default version of Node is still Node 20, any new terminal windows I open or an IDE that I open and that I execute things in the terminal inside the IDE will still be running Node 20. So we need to remember to use this nvm use 22 in any other environments that we want to use Node 22 in. With Node 22 available to us though, let's go ahead and create a new Nest project. So let's have a look at the Nest documentation. You can see that they've got some installation instructions up here, and you can use the Nest CLI to generate a standard starter project. However, they've also got an option for a TypeScript starter project by cloning their TypeScript starter repository. So we're going to do that. Instead of calling it project, though, I'm going to give it a different name. I'm going to call it NestJS Node 22. And once that's been cloned, we can then go into that folder, and I'm going to start my VS Code environment. As mentioned, by default, if we look at which version of Node we're running over here, we're still on version 20, so we need to remember to come in here and say we want to use version 22. So now if I do a Node version, we can see we're using Node 22 there. The next step is to run npm install. We've cloned the repository, but we haven't installed the packages yet. And once that's finished running, we can run npm run start dev, and with that running we can then open localhost port 3000 and see that our example app is running. Now we can see though, if we have a look at some of the documentation around Node 22, we can see if we look at the interoperability with CommonJS down here, that some of the functionality is hidden behind an experimental require module flag. So we need to make sure that's passed into Node at runtime so that Node knows to unlock that experimental feature. But if we have a look in our package.json over here, we'll see that we're not actually calling Node directly. We're calling Nest in a number of places. We do call Node when we start the production environment. We're calling Nest when we're doing the development or debugging environments. We want to pass the flag in so that Node picks it up. In order to do that, we can pass it in as an environment variable. So if I just select the 4 Nest calls here and the Node call, we want to make sure that each of these is called with a flag passed in through the environment. We can do that by defining Node options to include experimental require module. So what happens here is that when this command gets run on the command line, the Node options equals in the parting quotes is interpreted by the command line to be a definition of an environment variable, and then it still runs nest build. So now when nest build runs, it'll then call node, and when node runs, it has access to that environment variable. An experimental require module gets passed into node at that point. So if I save that and we come down and we restart our environment, you'll see there's a little flash here of some red text saying that support for loading ES modules in require is experimental. We can see now that that experimental feature has been enabled in our version of Node 22 running underneath the Nest CLI. This means our application can require ESM-based modules that don't have a CommonJS counterpart. Arcjet is one of those. We release our SDKs as ESM-only, and in order to use them in NestJS previously, you'd have to make various changes to the way the application performs. You'd actually probably have converted your NestJS application to be an ESM application, ECMAScript module, instead of CommonJS. And that comes with a whole lot of other intricacies and complexities. One of them being that most of your includes need to end in .js in your code, and that's a lot of maintenance and overhead and various ways that your application can actually go wrong if you miss any of those things. So rather than doing that, this allows you to import Arcjet in the way you normally would in an ESM-based application, even though Nest is running as a CommonJS application. So if we stop our application and we install Arcjet Node, because NestJS is built on top of Node, that's the SDK that makes the most sense here. So we'll install that, and then we can come in and start setting up the environment variables that we need. So we'll create a new file here called .env, and I'm going to pull in the Arcjet key. The Arcjet key you can get from your Arcjet site configuration. If you come in and select the site and look under SDK configuration here, you'll find the Arcjet key. I'm going to copy that, and then I shall paste that in here, and we can save. The other thing we'll need to set is the Arcjet environment, and this we're going to set to development. What this does is tell Arcjet to accept localhost or local IP addresses as the source of the requests. In a production environment, we wouldn't accept those, but because we're in development, we want those to be accepted by the Arcjet SDK. Typically, this would be set in a node_environment variable, but NestJS doesn't set that, so we're going to set that as the Arcjet environment instead. So we can save that now and close that. We can close our package.json as well. Next, we'll want to install NestJS's configuration module that's going to allow us to pull this information out of the environment file. So we're going to run npm install nestjs config. With that done, we can now come and create a new file in source. I'm going to call this config. It's going to go into config directory and then configuration.ts. This is going to export a default function which returns various configuration information, including in our case the Arcjet key, which we're pulling out of the environment variable there. So I'll just clean that up, save and close. Now in this config folder over here, we also want to include a config module TS file. This is going to centralize all of our configuration information that can be used anywhere in our application. So we now know that the Arcjet key can be accessed wherever we need it in our application codebase. Finally, we will update our app module TS. So this is our core module for the main application. There are some changes we need to make here in order to make that key available too. If you come down to imports here, we want to make sure that the config module from config module here is available. So if I hit enter there, we've got our import line that's come in, and we're now providing our config module to the rest of the application. So I'll save and close that too. Now let's configure Arcjet itself. So under source, we'll create a new file. This is actually going to be an Arcjet folder. And in that, we're going to create an Arcjet service. That's going to be a TS file. And the code in here is going to initialize our Arcjet client with the configuration that we want for our application. And it's going to provide a function down here to protect any of the endpoints that we want to have protected. Now, in my case, I want to protect all of my endpoints. So let's create a new file over here, and we'll call this Arcjet middleware.ts. It's going to create a decision based on this protect method that was defined in the Arcjet service. And then we can go through the standard resolution process of deciding whether or not we return a 429 rate limiting error or a 403 in the case of shield. Otherwise, we're going to call next, which is going to call the next function in the middleware process. And in the unlikely event that Arcjet isn't able to respond in time, we've decided here that we're going to fail open. That is that if there is an error at all, then we're going to tell the middleware process to still go on to the next middleware handler. Now that we have this middleware defined, all we need to do is insert this into our application so that it gets called for every single route. If we open our app module TS again over here, we're going to need to call the Arcjet service as an additional provider. And in our app module itself, we're going to use configure to apply middleware across all of our routes. And in fact, the completion here looks good. We just need to call this import in and this import in. So for all of the routes, we're going to make sure that we apply the Arcjet middleware, which is going to make sure that shield and rate limiting are implemented. So we save that and come down here and start our application again. It started successfully, and if we load our application up over here, we will see that we're still getting a hello world response, and if we refresh it a couple more times, we'll eventually get a too many requests because we've hit that 10 requests per minute. And that's it. We've got Nest running on Node 22 with experimental require support enabled. Our application is running, rate limiting is working, and we've got an ESM-only package running in our CommonJS-based framework. This video accompanies a recent blog post of mine. If you prefer to consume this or want to see the code that you can copy and paste, head over there. There'll be a link in the description to that below as well. And the code that I generated today will also be going into a repository that I'll share with you. If it's not in the description below already, it will be very soon. I hope that's been useful to you. Let me know in the comments how it went. Let me know on Discord. There'll be a link to that in the description too. And until next time, have fun.